Hi everyone, today we're going to continue our talking about different shapes, and we're going to look at a specific type of shape here called the parallelogram. So we just spent a couple days working on interior and exterior of polygons. We're going to kind of hone in. So when you guys go to the very bottom of your page, we're going to just make a quick little like family tree here. All right, so what we're going to focus on for the rest of this unit is called quadrilaterals. And we know from our polygons that we just talked about, a quadrilateral is a four-sided polygon. Now there are many types of quadrilaterals. We're going to do tons and tons of look into those. So the first one we're going to be looking at today is what we call the parallelogram. And it looks something like this. And we're going to learn about the different properties of this parallelogram and kind of what it encompasses. Now the parallelogram has other things in its family. Some other things in its family are the rectangles, the rhombuses, and the square. We also have the trapezoid family, which in the trapezoid family we also have the isosceles trapezoid. Okay, oh, I'm not sure if I did that. So it has one thing, and we also have the kite family. Just has kites. Okay, so by the end of this unit, we're going to be studying all of these, all right? But today we're just going to be focusing on the parallelogram. So let's go back up here. So you notice we have the attributes of a parallelogram. It is essentially like what makes up a parallelogram or what we know about it. So we're gonna look at this picture here, parallelogram PQRS. We're gonna talk about what it is in words and then how to use it in symbols and looking at the above photo. So it says on the first thing is opposite sides are parallel. All right, so what that means when we see that, these little arrows represent the parallel. So in this picture, we know that side PS is parallel to QR. And we know that PQ is parallel to SR. Next one is opposite sides are congruent. All right, to show that opposite sides are congruent, okay, we use little tick marks. So this side will be the same length as this side. Tick mark, tick mark. So we have that PQ is congruent to SR, and that PS is congruent to QR. The next one says opposite angles are congruent. So that means that the opposite angle from P would be angle R, and the opposite angle from S would be angle Q. So I could say angle P is congruent to angle R, and angle S is congruent to angle Q. The next one has a little vocab word that we need to talk about. It says consecutive angles are supplementary. Now we've seen this word supplementary before this year. Supplementary means they add up to 180. Consecutive means they're next to each other. So that means, for example, angle P and S are next to each other, so they would add to 180. P and Q are next to each other, so they would add to 180. Q and R would add to 180. and S and R would add to 180. Okay, so if I write down two examples, I could say angle P plus angle S equals 180. I could say angle P plus angle Q equals 180, and so on and so forth. And finally, the last thing here. Diagonals bisect each other. Now, a diagonal is a line that connects two opposite angles, and it kind of cuts the shape in between. So, for example, diagonals here are PR is a diagonal, and SQ are a diagonal. And when we say bisect each other, that means they cut each other in half. So that means that this half is the same as this half, and this half is the same as that half. So I would say that SD is equal to DQ, and PD is equal to DR. It does not necessarily mean that they're all the exact same length, though. Just the diagonals are getting cut in half. So I know that's a lot of information, but we're going to try some problems where we're going to use these attributes and these properties to help us solve for variables and to kind of figure out different things. So the first one is, if it's a parallelogram, find the value of each variable. So look at this picture, I've got A and B as my variables. So we have to kind of see how they relate. So in this one here, I've got 2A on a side, and the other side I have here is 34. And those are opposite sides. Now, if you remember, opposite sides in a parallelogram are congruent. So I can say 2A equals 34, and I can solve for A. I would divide both sides by 2, and I'd get A equals 17. All right, the next thing I have an angle, and it says 8B, and the only other angle I have is this 112. For me, those are opposite angles. If you look at that, remember that opposite angles are congruent. So I can say 8B equals 112. Divide both sides by 8, and I get B is 14. Example 2, it tells us it's a parallelogram. We need to determine X and Y. So we kind of got a lot going on here for this one. So if I look at this, all right, I see that they give us 5x, 55, 60, and 2y. Now, 5x and 2y are opposite angles, which means they would be equal, but that won't really help us because we have x's and y's. What if I combine these two into one big angle here? If I have 60 and 55, that whole angle would actually equal 115. Now let's see how the x's and y's relate to that. How would, oh, can't really see that one, can you? How would 115 and 5x relate to each other? Well, those angles are consecutive or next to, which if you remember our properties, if they're consecutive or next to, they are supplementary, they would add to 180. So I can say 115 plus 5x equals 180 and solve for x. I can subtract that 115, so I get 5x equals 65. Divide both sides by 5, and I get x equals 13. I can do the same thing if I wanted to for the 115 and 2y. So I can say 2y plus 115 equals 180. 2y equals 65, which means that y is 32.5. Once I find one of the variables, I can set 2y equal to 5x and then go from there as well. There's going to be a lot of different ways you can solve these problems. All right, let's look at example 3. It says find the values of x and y in parallelogram ABCD. So let's look at x first. X is right here, okay? And that is on the diagonal. That is on diagonal DB. So the other thing that's on the diagonal is 24. And if we remember from above, diagonals bisect each other, which means that this 6x should be the exact same length as that 24. So I can say 6x equals 24, which means x equals 4. Whereas this 4y is on diagonal AC, and 18 is on the diagonal. So since those are getting bisected, they would be equal to each other. So I'd have 4y equals 18. Divide both sides by 4, and I get y equals 4.5. And finally, example 4 here, determine values of x and y again. All right, so let's look at this. I'm gonna look at x first. So x is right here, that's that little angle, and it has this marking here. Okay, that marking and this marking mean they're going to be congruent or the same, so I can say that this is 3x. Now, we don't really have any other angles, though, besides this 90 degrees. If I look at that, right here, I've got this little triangle going on. And we can remember that triangles add up to 180, so I can say 3x plus 90 equals 180. That would be 6x plus 90 equals 180. Subtract both sides by 90, divided by 6, and I get 15. For the y, I've got 2y here, and it's on a diagonal, and that diagonal is right here. The only other thing on the diagonal is that 12, and remember the diagonals bisect each other, so that means that 2y should be the same as 12. So 2y equals 12, divide both sides by 2, and I get y equals 6.